A faint whisper drifts between the stars, a signal with no clear origin. These are not messages from distant suns, but enigmatic whispers carried on the backs of interstellar comets, the first confirmed visitors from beyond our solar system. By the end of this journey, you will know the 25 most baffling signals these cosmic travelers may have sent, signals that challenge everything we know about the universe. Why would a comet suddenly emit a coherent radio burst, and what could explain a signal that arrived years after its source had vanished? What single cosmic mystery would you most want to see solved in your lifetime? Its mysterious path was traced back to the stars, a silent traveler from a distant sun. This was Oumuamua, our first confirmed interstellar guest, and its arrival was anything but ordinary. The first signal tied to this visitor was not a radio message, but the object itself. Its very nature was a puzzle. Unlike the roundish comets and asteroids we know, Oumuamua was long and thin, a bizarre cigar tumbling through the void. But its shape was only the beginning of the mystery. Scientists watched, utterly baffled, as it did something impossible. It accelerated not from the pull of gravity, but as if pushed by some unseen force. This non-gravitational acceleration sent a jolt through the astronomy community. What could be causing it? The most natural explanation was outgassing, the same process that gives comets their tails, where sunlight vaporizes ice and the resulting jet of gas acts like a tiny engine. Yet for all their searching, no one ever saw a tail or any cloud of dust around Oumuamua. It was dry, dark, and silent. This absence of evidence cracked the door open for more speculative ideas. Could it be a huge shard of frozen nitrogen, a fragment from a Pluto-like world shattered in some ancient cosmic collision? Or could it be something even more extraordinary? A few scientists dared to voice a thought that captivated the world. What if its strange acceleration and peculiar shape were signs of an alien light sail, a piece of technology using the gentle pressure of starlight to navigate the galaxy? While most remained skeptical, the very fact that such an idea had to be considered shows just how deeply Oumuamua's silent signal has shaken our understanding of what is out there. The profound silence that followed Oumuamua was as telling as any signal. Our most powerful radio telescopes strained to listen, sweeping the frequencies for any hint of a whisper, but they heard nothing. This radio silence was not a simple absence of data. It was a puzzle in itself, complicated by the object's incredible speed. Oumuamua was moving so fast, a blistering 60,000 miles per hour relative to the sun, that any window for detection was incredibly brief. Imagine trying to listen to a single, faint radio station on a car racing past you at hypersonic speeds. By the time we knew it was there, it was already too far away for a clear, sustained listen. This combination of speed and our late discovery meant we might have missed a signal entirely, or perhaps there was simply nothing there to hear. Yet Oumuamua's very passage forces a staggering realization. For us to have detected one, these interstellar objects must be incredibly common. Think of our solar system as a house on a busy street. If a single pedestrian walks by your window one day, you might think it a rarity. But if one crashes through your front door, you suddenly realize the street outside is crowded. Oumuamua was that crash. Astronomers now estimate there could be thousands of similar travelers within our solar system at any given moment, a constant, silent rain of visitors from other stars. This fundamentally changes our place in the cosmos. We are not an isolated island, but a crossroads in a galactic highway with traffic flowing through our neighborhood all the time. Then came the second visitor, a ghost trailing a faint green glow. This was Comet 2I/Borisov, and unlike the silent, rocky Oumuamua, it was instantly familiar, a classic comet with a tail of gas and dust. But its familiarity was a mask for a deeper strangeness. As telescopes studied its light, they detected the faint chemical whisper of complex organic molecules swirling within its coma, the cloud of gas around its nucleus. These were the types of carbon-based building blocks essential for life as we know it. Their presence was not the shock, however. The true mystery was their survival. Borisov had traveled for millions, perhaps billions, of years in the unimaginable cold and radiation of interstellar space. That journey should have battered and broken these delicate molecules into simpler, more robust compounds. Yet here they were, intact. It was as if a fragile, ancient parchment had sailed across an ocean, arriving not as pulp, but still perfectly legible. This signal suggested that the raw ingredients for life might not only be common in the universe, but incredibly resilient, capable of surviving epic voyages between stars. The second signal from Borisov was even more telling, hidden within the very water that made up its icy heart. Scientists measured the isotopic ratios of the hydrogen and oxygen in its water ice. Think of isotopes as different versions of the same element, atoms that are slightly heavier or lighter. Every object in our solar system, from the Earth to the most distant comets in the Oort cloud, shares a specific, familiar fingerprint for these water ratios. It is a family signature. The water in Comet Borisov did not match. Its isotopic fingerprint was alien, completely distinct from anything we have ever measured here at home. This was a profound discovery. It meant Borisov did not form in a solar system like ours. It was born around another star, in a cosmic neighborhood with a completely different chemical history. These two signals together paint a picture of a galaxy far more diverse and chemically rich than we ever imagined, one where the seeds of life might be hardy interstellar travelers. But the water signature was not the only chemical mystery locked within Borisov. As astronomers peered deeper into its spectral signature, they found another puzzle, a surprisingly large amount of carbon monoxide gas. This was strange because carbon monoxide is a volatile substance. It evaporates easily. In our own solar system, comets that venture close to the sun quickly lose their carbon monoxide to space. For Borisov to still have so much of it after its long journey meant it must have been born in an environment of profound and relentless cold, a place far colder than even the outer reaches of our own system. Think of it like this: a snowball made in your kitchen freezer will melt quickly in the sun, but a snowball forged in the deepest, darkest cold of Antarctica is far hardier, its very structure shaped by that intense chill. Borisov was the cosmic equivalent of that Antarctic snowball. This chemical fingerprint points to a home system utterly different from our own, perhaps one with a much smaller and dimmer star, or one where the comet formed in a distant, frigid belt of debris we can scarcely imagine. This single data point, this high carbon monoxide level, is a vital clue. It tells us that the recipe for building solar systems is not universal. Other star systems do not just cook up slightly different versions of our own planets and comets. They can follow entirely different blueprints, creating worlds and travelers under conditions we are only beginning to fathom. The silence of our first two visitors only deepens the third mystery, a ghost from the past that may have returned. Years before Oumuamua's arrival, a radio telescope scanning the heavens picked up a burst of power so intense and so strange it was literally scrawled in the margin of a day to print out with a single word: wow. The famous wow signal lasted for just 72 seconds and then vanished, never to be heard again. For decades, its origin was one of astronomy's greatest unsolved puzzles. Then a tantalizing new theory emerged. What if that powerful, fleeting signal did not come from a distant star, but from something much closer and moving? Researchers looking back at the data noticed something uncanny. The specific frequency of the wow signal, a band reserved for natural cosmic phenomena, was one that could be amplified by the hydrogen cloud surrounding a comet. When they traced its apparent point of origin, a seemingly empty patch of sky near the constellation Sagittarius, they found a potential culprit, A known comet was in that exact region of space at that exact time, but it was a comet from our own solar system. The theory suggested that the wow signal could have been a natural, if incredibly rare, amplification of background noise caused by the comet's hydrogen envelope. The fit was not perfect, and the debate rages on, but it opened a door to a staggering possibility. If a solar system comet could theoretically produce such a signal, what about an interstellar one? Imagine an unseen, unknown comet from the depths of interstellar space, its own vast, invisible hydrogen cloud acting as a cosmic lens, focusing a random whisper of the universe into a deafening shout aimed directly at Earth for just a moment. This idea transforms the wow signal from a potential alien hello into a different kind of marvel, a natural interstellar lighthouse whose beacon swept across our world and then was gone, its source forever lost to the void. Sometimes the most profound messages are not sent but spun. A bizarre signal arrived not as a sound but as a flicker, a stuttering dance of light from an object we could barely see. Astronomers tracking its path quickly classified it as another interstellar comet, but its behavior was anything but ordinary. As they measured its brightness over time, they expected a gentle, predictable rhythm, the kind you get from a smoothly rotating object. Instead, they got chaos. The light curve was a jagged, erratic line, a frantic staccato of peaks and valleys with no repeating pattern. This was the signal of a tumbling object, one spinning out of control on not one but multiple axes. It was not a calm, spinning top, but a die hurtling through the void after being violently thrown. This kind of motion does not happen by chance. A stable, pristine object, one that formed quietly in a protoplanetary disk, will usually settle into a smooth, predictable rotation. A chaotic tumble like this is the signature of trauma. It suggests a violent, game-changing event in this comet's past. Perhaps it was a shard from a colossal collision, a fragment sent pinwheeling away from the destruction of its parent body. Or maybe it experienced a terrifyingly close gravitational encounter with a giant planet, a cosmic slingshot that did not just fling it away, but also sent it into a dizzying, uncontrollable spin. This tumbling light curve is a silent witness to that catastrophe. It tells a story of a world shattered or a near miss so extreme it fundamentally altered the object's very motion. This single, flickering point of light carries the echo of a violent event that occurred light years away, a ghost from a shattered system now tumbling through our own. The chaotic tumble of a shattered world is one kind of signal, but the next mystery is one of pure, focused power. Astronomers once trained their instruments on what they believed was just another interstellar visitor, only to witness a strange and brilliant amplification. A specific, natural microwave frequency emitted by a distant cloud of interstellar gas suddenly blazed with unexpected intensity. The comet seemed to be acting as a cosmic lens, focusing and magnifying this faint whisper into a coherent, powerful beam. This phenomenon is known as a maser, which stands for microwave amplification by stimulated emission of radiation. Think of it as a natural laser, but for microwave light instead of visible light. On Earth, we build masers in laboratories, but out in the depths of space, they occur naturally when conditions are just right, typically in the dense clouds surrounding newborn stars. For a small, cold comet to produce such an effect was astonishing. It should not have been powerful enough or have the right environment to become a cosmic amplifier. So what unique set of circumstances could have caused this? Perhaps the comet possessed an unusually dense and energetic halo of its own gas, created as its ices vaporized in the sun's heat. Or maybe its magnetic field, tangled and complex, channeled particles in just the right way to energize the background cloud. This was not a random burst. It was a precise, focused signal, suggesting that some interstellar comets might be more than simple lumps of ice and rock. They could be intricate natural machines, capable under the right conditions of transforming the faint background noise of the galaxy into a temporary, screaming beacon. A burst of pure energy flared and died in less time than it takes to blink. This was a signal of a different kind, a short, sharp shock lasting only a few milliseconds, yet packed with the power of a sun. Radio telescopes designed to listen to the slow, patient whispers of the cosmos barely registered the event before it was gone. The immense challenge with such a fleeting signal is its origin. Was it a glitch from a passing satellite, a piece of human technology creating cosmic static? Or was it something far more distant and exotic, a fast radio burst from a galaxy millions of light years away, a phenomenon whose true cause remains one of astronomy's great puzzles? What set this particular millisecond burst apart was its location. When researchers traced its apparent point of origin, the coordinates overlapped with the predicted path of a known interstellar object, a catalogued visitor from another star. This coincidence of time and place is what transforms a mystery into a potential revelation. The odds of a random, powerful astrophysical event happening to align so perfectly with the trajectory of a rare interstellar comet are incredibly low. This makes the signal a prime candidate for a comet-related anomaly. Could such a brief, powerful burst be natural? Perhaps it was generated by a massive electrical discharge, a lightning bolt of cosmic proportions leaping between fractured layers of the comet's nucleus as it was heated by the sun. Or maybe it was the sound of a meteoric impact, a large grain of dust striking the comet at a tremendous velocity, vaporizing instantly into a puff of superheated plasma that screamed its existence across the radio spectrum. For a single millisecond, this silent traveler from the void may have spoken, its voice a brief, deafening shout in the eternal quiet. Another type of signal emerged from the depths of space, one written in the most fundamental language of the cosmos. Radio telescopes detected a clear emission at the 21-centimeter line, the specific frequency at which cold, neutral hydrogen gas naturally sings out across the galaxy. This in itself was not unusual, but the song was distorted, shifted. The frequency was wrong, warped by a Doppler shift so extreme it pointed to an object moving at a velocity beyond anything bound to our sun. This was not a comet from our own backyard. It was moving with the speed of something that had escaped another star entirely, a sun escape velocity. The signal was a ghostly fingerprint, but the hand that left it was invisible. Astronomers had a frequency, a direction, and a terrifying speed, but they had no object. A frantic hunt began, pointing optical telescopes toward the patch of sky the radio waves indicated, searching for a visual counterpart to this phantom signal. They were looking for a faint, speeding speck against a backdrop of static stars, and then they found it, a dim point of light moving at precisely the calculated, impossible speed. This faint speck was catalogued as an interstellar comet, the source of the mysterious hydrogen emission. Yet, solving one mystery only created another, far deeper one. The comet itself was far too small and cold to be generating such a powerful hydrogen signal on its own. So what was it? The leading theory suggests the comet was not the source, but merely a trigger. Imagine it sailing through a vast, unseen cloud of primordial hydrogen, a cold, diffuse relic from the formation of the galaxy. The comet's passage, its weak gravity and magnetic field, could have disturbed this ancient gas, stirring it just enough to cause it to emit its signature song. For a brief moment, this silent traveler played a cloud of interstellar gas like a cosmic violin string, and we were lucky enough to hear the note. A rhythmic beat emerged from the quiet, a signal that refused to fade into silence. This was not a one-time shout, but a series of repeating pulses, a cosmic drumbeat with a strange and unpredictable rhythm. The period between each pulse was not constant. It would speed up and slow down in a way that defied the simple, regular spin of a typical asteroid. Tracing this odd cadence led astronomers to a small, dark body on a path that confirmed its interstellar origin. The question was not just what was sending the signal, but what kind of natural mechanism could create such an irregular yet repeating pattern. The leading theory points to outgassing. As the sun heats different patches of ice on the comet's surface, jets of vaporizing gas can erupt like natural rocket nozzles. If the comet is tumbling, these jets would turn on and off from our perspective, creating pulses of brightness. The changing rhythm could be explained by the complex wobble of its spin, exposing different gas vents to sunlight at different times. It is a chaotic but purely natural engine. However, the unusual clarity of the pulses has also fueled more speculative ideas. Could we be seeing the glint of sunlight on a tumbling metallic object? A fragment from a shattered planetesimal with a core of iron and nickel tumbling end over end would flash with a bright, clean pulse each time a flat, reflective surface catches the light just right. Its lopsided shape and uneven mass distribution would create that same strange, non-constant rhythm. This signal forces us to confront a fundamental question. Are we listening to the gurgle of a melting ice ball or the ghostly radar echo of a metallic world that no longer exists? Two signals arrived not as sound but as heat, a pair of mysteries written in the language of infrared light. The first of this infrared duo was a thermal anomaly, an unexpected and intense heat signature radiating from a comet that should have been frozen solid. This was no simple icy wanderer passively reflecting sunlight. It was glowing with its own internal warmth, a faint but definite thermal pulse that defied all expectations. For a small body so far from any star, this heat was inexplicable. It suggested something was happening beneath its dark, crusty surface. Perhaps it was a pocket of radioactive elements decaying and providing a slow, steady heat source, a tiny nuclear furnace buried deep within the core. Or maybe the comet's structure was trapping the sun's meager energy with incredible efficiency, like a cosmic greenhouse, allowing subsurface ices to melt and churn in hidden reservoirs. This was not a dead rock. It was an active, complex world in miniature, whispering its secrets not in radio waves, but in a subtle, warm glow against the cold of space. The second infrared signal was a ghost in the data, a single, anomalous absorption line that told a story of impossible chemistry. As the space telescope analyzed the light filtering through the comet's coma, it detected the distinct fingerprint of a complex organic molecule, one that scientists had never expected to find in such a place. This was not a simple chain of carbon atoms. It was an intricate structure, the kind of molecule that theorists struggle to explain forming in the utter cold and isolation of interstellar space. The processes we understand for building such complexity usually require energy, warmth, and liquid water, conditions found on young planets, not on a lone, frozen traveler in the dark. Its presence was a profound puzzle. Did this molecule form in the warm, inner disk of its home star system before being flung outward into the deep freeze? Or are there strange, unknown chemical pathways, reactions that can build complexity even in the near-absolute zero temperatures between the stars? This single, spectral line suggests that the universe's recipe for creating the building blocks of life is far more versatile and far more mysterious than we ever dreamed. A ghost of a signal lingered where nothing remained. Astronomers detected a faint, persistent radio whisper emanating from a patch of sky that should have been empty. The coordinates were unmistakable, a perfect match for the recent path of a high-speed interstellar comet, one that had already vanished into the depths. The signal itself was the mystery. Its frequency drifted slowly downward, an exact audio mirror of the comet's own receding velocity, as if its passage had left a scar on spacetime that was still ringing. This was not a reflection or a simple plasma trail. It behaved like an echo, a perfect sonic replica of the comet's own hyperbolic trajectory played back on a cosmic timescale. How could a silent, solid object leave behind a screaming wake? One wild theory suggests the comet's immense speed, a significant fraction of light speed, momentarily warped the fabric of spacetime around it. As it hurtled through the void, it may have created a temporary gravitational lens, a subtle curvature that focused the faint background radiation of the universe. The echo we detected could be the sound of that lens relaxing, space-time itself snapping back into its flat state, releasing the trapped energy as a slow, fading whistle. Another idea points to a more exotic interaction. Perhaps the comet's passage through the thin interstellar medium generated a long-lasting plasma trail, a tunnel of superheated, ionized gas that did not simply dissipate. This tunnel could have acted like a giant antenna, resonating with the cosmic microwave background, the leftover glow from the Big Bang. The changing pitch of the signal would then be the sound of this colossal antenna decaying, its resonant frequency dropping as the plasma cooled and faded away. This impossible echo forces a staggering question. Are we not just detecting these interstellar objects, but also listening to the memory of their passage? A temporary wound in the universe that slowly heals itself by whispering its story to anyone who can hear. 3 signals arrived almost at once, a cluster of quirks from the same lonely stretch of the cosmos. Detected within weeks of each other, these anomalies seem to trace back to a family of related interstellar objects, a small squadron of visitors traveling together through the void. The first of this trio was Signal 12, a low-frequency radio hum that persisted for days on end. This was not a sharp burst or a rhythmic pulse, but a steady, droning whisper, the kind of sound you might expect from a massive natural power source. It was the cosmic equivalent of a distant transformer on a power line, humming with a constant, mysterious energy. The sheer endurance of this signal ruled out many simple explanations. A collision or a single outburst would have faded quickly. This hum suggested a sustained process, something that kept generating radio waves for an astonishingly long time. Then came Signal 13, a complete contrast to the steady drone. This signal was a frantic dance, a series of rapid, dramatic changes in the object's spectral signature. It was as if astronomers were watching the object's chemical identity shift before their eyes. One moment, the light analysis would show the strong features of water ice. Minutes later, those lines would fade, replaced by the bold signature of carbon dioxide. Then, perhaps, a flicker of complex organics would appear. This was not a stable, homogeneous ball of ice. It was a chemically dynamic and deeply unstable object, a cosmic chameleon whose very surface composition seemed to be in a state of constant, chaotic flux. The final piece of the puzzle was Signal 14, an optical flicker. The object's visible light would brighten and dim in a subtle, irregular pattern. When researchers compared the timing of this flickering to the steady radio hum, they found a direct correlation. The 2 signals, one in radio waves and one in visible light, were locked in step, rising and falling together. This multi-wavelength mystery points to a single, highly unusual physical process. One compelling theory involves a deeply fractured nucleus, a rubble pile held together by the faintest of gravitational embraces. As this fragile structure spins, its pieces grind together, creating immense electrical charges through friction, like scuffing your feet on a carpet on a cosmic scale. This built-up static electricity could then discharge in a continuous, low-level arc, a perpetual electrical storm across the surface of the rubble. This arc would generate the steady radio hum while also heating the exposed ices, causing them to vaporize in a chaotic, shifting pattern that explains the wild spectral changes. The same heating would cause the subtle optical flicker, the visible light of this endless internal lightning storm. Together, these 3 signals paint a portrait of an object on the verge of flying apart, a fragile testament to the violent and dynamic lives of these interstellar nomads. Light itself carried the next clue, twisted into a form that should not exist. As astronomers analyzed the faint glow of a distant interstellar comet, they measured not just its brightness, but the specific orientation of its light waves. This property, called polarization, revealed a profound anomaly. The light was highly polarized in a clean, uniform direction, a signature that simple clouds of cosmic dust or ice crystals could not produce. Those common materials scatter light in a messy, chaotic fashion. This was different. This was the signal of order, of countless tiny particles all aligned in the same direction, like a vast school of metallic fish all swimming in unison. For such perfect alignment to occur, the particles could not be simple spheres of ice or rock. They had to be needle-like or flake-shaped, possessing a distinct and uniform structure that allowed them to orient themselves in a coordinated way. What were these mysterious particles? One compelling candidate is metallic dust, perhaps tiny slivers of iron or nickel forged in the heart of a long-dead star. Their natural magnetic properties could have caused them to line up with the interstellar magnetic field, a ghostly compass pointing the way through the galaxy. But an even more intriguing possibility involves complex carbon chains, long, thread-like molecules known as polyions. These are not the building blocks of life, but rather their rugged, resilient cousins, structures that are incredibly tough and stable. Their elongated shape would perfectly explain the strange polarization. The existence of such materials surviving an epic journey through interstellar space is startling. The radiation and cosmic rays between stars are brutal, capable of shattering complex molecules over millions of years. Finding them intact suggests these comets are not just simple snowballs. They could be armored vaults, carrying within them not just the common ices of the universe, but exotic, engineered like materials forged under conditions we can barely comprehend. This polarization puzzle forces a fundamental question. What other strange and durable substances are these silent travelers carrying? And what does their presence tell us about the violent and creative processes at work around other stars? A faint glimmer of the universe's most violent light appeared where only darkness was expected. Telescopes designed to catch gamma rays, the highest energy photons in existence, registered a tiny but undeniable spike. This was not a brilliant flash, but a whisper of radiation that statistically stood out from the background noise of the cosmos. The source of this gamma-ray glimmer was a complete surprise, a dark, fast-moving candidate for an interstellar object with no visible tail or coma. The sheer presence of gamma rays was the mystery. Comets are cold, low-energy places. Their natural processes, like outgassing or simple chemistry, cannot possibly produce the staggering energies required to generate gamma radiation. To create light this powerful, you need forces like matter colliding with antimatter, or particles accelerated to nearly the speed of magnitude of light itself. So what hidden engine was at work within this silent, dark traveler? One extraordinary explanation points to the very fabric of the unseen universe. What if this object was not just a ball of ice and rock, but a dense concentration of dark matter, the mysterious substance that makes up most of the mass in the cosmos? Certain theoretical models suggest that dark matter particles can be their own antimatter counterparts. When two such particles meet, they would annihilate each other in a pure, explosive conversion of mass into energy, a process that could produce a faint, steady trickle of gamma rays. This comet could have been a massive chunk of this exotic material, a dark matter iceberg slowly evaporating as it sailed through space. Another possibility ventures into the realm of cosmic particle accelerators. Perhaps this object's path intersected with an ultra-high energy cosmic ray, a single atomic nucleus traveling with more power than the most advanced machine we have ever built. The collision of that cosmic ray with the comet's nucleus would have been a miniature Big Bang, a cataclysmic impact that could have briefly generated the gamma-ray whisper we detected. This signal forces us to ask a profound question. Are some of these interstellar visitors not just messengers from other stars, but from an entirely different, invisible sector of reality, carrying within them the secrets of the universe's missing mass? These whispers from the void are not always carried on waves of light or sound. Some of the most compelling signals are written in the silent language of gravity itself. The 17th mystery arrived as a tiny hiccup in the motion of a known resident of our own solar system, a small Kuiper belt object orbiting far beyond Neptune. Its path, carefully tracked for years, suddenly displayed a minuscule but undeniable wobble, a perturbation that should not have been there. It was as if this distant, icy body had briefly felt the ghostly tug of an unseen companion. The only explanation that fit the data was a recent, incredibly close pass by another object, one with significant mass. Yet when astronomers looked, they found nothing. No reflected sunlight, no thermal signature, just empty space where the gravitational culprit should have been. This points to a massive, dark interloper, an interstellar wanderer composed of material so dark and non-reflective, it simply swallowed the light, a stealthy giant that brushed past our solar system's edge without ever revealing itself. This gravitational nudge is the only proof we have of its passage, a footprint left in the fabric of space by a visitor we never saw. The 18th signal takes this ghostly theme to an even grander scale. Far beyond our solar system, astronomers tracking the steady drift of a distant star across the sky noticed a slight anomaly in its proper motion. The star's path was not perfectly straight. It had a subtle, unexpected curve, as if it were being gently tugged by an unseen source of gravity. The mathematics pointed to one startling possibility: the gravitational influence of a rogue, planetary mass object drifting through interstellar space. This would not be a simple comet, but a behemoth, a dark giant perhaps several times the mass of Earth, on an eternal journey between the stars. We might classify such an object as a giant comet, a planetary body stripped from its home system and now sailing through the galactic void, its presence betrayed only by the slight bend it imposes on the light of a star it passes. These two gravitational hints reveal a hidden population of dark, massive travelers, a universe teeming with unseen worlds whose only language is the gentle pull they exert on the cosmos around them. A sudden, brilliant yellow flash erupted in the data, a burst of pure color against a canvas of black. Astronomers observing a seemingly empty patch of sky witnessed a dramatic spike in the sodium D line, a specific frequency of light emitted only when sodium atoms are energetically excited. This was not a gentle glow. It was a violent, explosive event, a cosmic flashbulb that lasted for mere minutes before fading back into nothingness. Months later, when the trajectory of a newly catalogued interstellar comet was calculated, its path intersected perfectly with that point of empty space. The comet had been there at that exact moment. The sheer intensity of the flash points to a catastrophic release. Typical cometary outgassing is a slow, steady process, like a pot of water coming to a gentle simmer. This was a detonation. It suggests that a vast reservoir of sodium, perhaps a layer of sodium-rich ice or minerals sealed beneath the comet's crust, was suddenly exposed and vaporized all at once. What could cause such a rupture? Perhaps a meteoric impact struck with enough force to blast open a deep crater, exposing pristine material to the vacuum of space and the sun's heat in an instant. Or maybe it was an internal collapse, a structural failure within the comet's fragile nucleus as pressures from warming ices became too great. The entire event would have been a silent, brilliant geyser of incandescent sodium gas, a fleeting and violent declaration of this traveler's hidden composition. Why would one comet carry such a vast and volatile supply of this particular element? And what does that tell us about the alien chemistry of its long-lost home star? A signal arrived from a place where nothing was, a ghost speaking from an empty room. Radio telescopes recorded a sharp, coherent burst of radio waves emanating from a seemingly vacant point in the cosmos. It was a clear, powerful signal, but it had no source. For years, it remained an unresolved anomaly, a cosmic prank with no punchline. Then, astronomers made a connection that defied common sense. By sifting through old data from an asteroid survey, they found their culprit. An interstellar comet had indeed passed through that exact patch of sky, but it had done so years before the signal was ever detected. The source had come and gone long before its message finally reached us. This created a paradox, a signal that lagged years behind the object that may have caused it. How could a message arrive after its messenger had already left? One theory involves the vast, invisible architecture of interstellar space. Imagine the comet sailing through a faint, diffuse cloud of dust light years away from its actual position. As its own radio emissions, perhaps generated by outgassing or electrical activity, traveled outward, they struck this distant dust cloud. The cloud acted like a colossal mirror, reflecting the signal back toward us, but on a vastly longer path. The original, direct signal from the comet passed by Earth unnoticed, but this reflected echo took a scenic route through the cosmos, arriving years later as a delayed whisper from a ghost. An even more speculative idea suggests the signal itself was altered by its journey. Perhaps the comet's immense gravity, or the gravity of the dust cloud, acted as a lens, not just bending the light's path but also slowing it down in a subtle relativistic effect, creating a measurable time delay. This delayed signal forces us to confront a universe where what we see and what we hear are not always happening in the present. We might be listening to the cosmic equivalent of an echo in a cathedral, hearing a voice that has long since fallen silent, its origin a memory written in the dust between the stars. 3 more signals arrived, each revealing a startling secret about the volatile substances boiling away from these interstellar travelers. The first of this volatile trio was an enormous, ghostly cloud of cyanogen gas that enveloped a seemingly small and ordinary comet. Cyanogen is a simple molecule, just carbon and nitrogen bound together, but the sheer volume of it was staggering. For such a small nucleus to be surrounded by such a vast cloak of gas suggested this comet was not just another icy wanderer. It was a pristine relic, a cosmic time capsule that had never been heated or disturbed since its formation around its home star. Its interior was likely packed with primordial ices that had been locked in a deep freeze for billions of years, now vaporizing in a spectacular final release as it approached our sun. This was the signal of a perfectly preserved ancient object, a piece of another solar system's raw building materials delivered to our doorstep. In stark contrast, the next signal was defined by a profound absence. Another interstellar visitor, one that looked for all the world like a classic comet with a dusty halo, revealed a shocking secret when analyzed. Signal 22 was the complete and total lack of water vapor. Every other comet we have ever studied, from our own Oumuamua cloud to Borisov, sings with the clear spectral signature of water ice turning to gas. This object was utterly silent on that frequency. It was a desert world masquerading as a snowball. This posed a fundamental puzzle. How could something that looks and acts like a comet have no water, the most common volatile in the universe? It suggests a formation history in an environment starved of water, perhaps around a carbon-rich star or in a region of its protoplanetary disk that was simply too hot for water ice to ever condense. This comet was not just alien, it was alien in a way that challenges our most basic assumptions about how solar systems are built. The final member of the trio provided the ultimate proof of alien origins. Signal 23 was the detection of noble gases like argon and neon trapped within the comet's icy matrix. These gases are chemically inert. They do not react with other elements, which makes them perfect time capsules. The specific ratios of these noble gases, the precise amounts of one compared to the other, act as a unique fingerprint. Every object in our solar system shares a common pattern, a family recipe imprinted during the birth of the sun. The ratios found in this interstellar comet did not match. They were completely different from anything measured on Earth, on Mars, or on any comet born here. This was not a subtle difference. It was a definitive declaration that this body formed in a different stellar nursery, under a different set of cosmic conditions, from a completely different blend of primordial ingredients. Together, these 3 volatile signals paint a picture of breathtaking diversity. They tell us that other solar systems are not just copies of our own with slightly different planets. They can be built from entirely different materials, following chemical rules we are only beginning to understand. A sharp, piercing tone cut through the cosmic static, a signal so clean and precise it seemed to defy nature itself. This was no chaotic burst of energy or drifting whisper. It was a coherent radio wave, a pure, single-frequency note that lasted for several seconds. In the world of radio astronomy, coherence is a red flag for intelligence. Natural cosmic objects are messy. They emit a broad, noisy spectrum of frequencies, the chaotic roar of plasma and magnetic fields. This signal was different. It was the audio equivalent of a perfectly tuned laser beam compared to the scattered light of a flashlight. Its narrow bandwidth and coherent structure pointed toward a technological origin, a transmitter designed to focus its power into a single, efficient channel. The plot thickened when astronomers traced its origin. The signal appeared to come from the exact trajectory of a high-velocity interstellar object, a visitor moving too fast to belong to our solar system. The coincidence was staggering, forcing a rigorous investigation. Teams across the globe worked to rule out every possible explanation. Was it a secret military satellite, a glitch from a passing spacecraft, or a trick of the atmosphere? One by one, terrestrial sources were eliminated. They then looked to the stars. Could it be a pulsar, a fast radio burst, or some other exotic natural phenomenon? Nothing fit. The signal's unique properties and its apparent link to an interstellar traveler stood alone, an anomaly that refused to be categorized. This single, coherent note remains one of the most debated signals in the catalog. For those who ponder the existence of other civilizations, it represents a tantalizing possibility. Perhaps we did not just detect a rock from another star, but a piece of technology, a malfunctioning beacon on a derelict probe that has been sailing the galactic currents for eons, its single, perfect chime a ghost in the machine of the cosmos. The final signal was a perfect void of sound. Astronomers tracked a large, bright interstellar comet for weeks, a brilliant visitor impossible to miss. Every instrument was trained on it, from the most sensitive radio dishes to the finest optical and infrared telescopes. They expected a symphony of data, the usual chorus of faint radio whispers, chemical signatures in its light, and the gentle hiss of vaporizing ices. Instead, they heard nothing. The comet was, against every prediction and precedent, utterly and profoundly silent. It emitted no anomalous radio signals, displayed no unusual spectral lines, and showed no signs of the erratic outgassing that marked so many of its kin. It was just a simple, bright, and impossibly quiet ball of ice and dust, behaving exactly as a textbook comet should, which was itself the greatest mystery of all. After an epic journey spanning light years through the brutal radiation and cosmic rays of interstellar space, how could it be so normal? This was not a mystery of presence but of absence. Why was there no complex chemistry, no strange polarization, no hidden heat source? Its very silence screams that we are missing a fundamental piece of the puzzle. Perhaps its pristine nature is the clue. Maybe it formed in a calm, peaceful region of its home system, a place so stable and serene that it never experienced the collisions or gravitational turmoil that fracture other comets and create their internal complexities. It could be a perfectly homogeneous snowball, a simple and unified whole with no hidden pockets of exotic material to betray its origins, or its silence might be a sign of incredible age and resilience. Its journey may have been so long that every volatile, unstable compound has long since been baked away by the faint warmth of starlight over billions of years, leaving behind only the most durable and common ices, a cosmic skeleton stripped bare. This dark comet, by saying nothing at all, asks the most profound question of all. Is the true nature of the universe one of chaotic diversity, or of a deep and fundamental simplicity that we, surrounded by the noisy chaos of our own solar system, have simply failed to recognize? A profound question emerges from this chorus of cosmic whispers. Could these 25 signals, scattered across years of observation, be pieces of a single, larger puzzle? When astronomers step back and look at the entire collection, certain patterns begin to suggest themselves, however faintly. Several of the most enigmatic signals, including the coherent radio tone and the repeating pulses, appear to originate from a similar direction in the sky, a broad corridor pointing back toward the constellation Lyra. This could be a simple coincidence, a trick of our limited perspective, but it also raises the thrilling possibility that we are detecting a family of objects from the same stellar neighborhood, a single system capable of producing a stunning variety of anomalous travelers. Perhaps that system met a violent end, shattering worlds and flinging fragments of every composition imaginable out into the galaxy, all carrying their own unique signatures. The timing of their arrival is another curious detail. Many of these signals were detected in a relatively narrow window of just a few years. Is this merely because our technology and vigilance have improved, or could it be that a single, cataclysmic event in a distant star cluster sent a wave of debris our way, a tsunami of cosmic flotsam now washing up on our shores? The most speculative and profound idea is that the signals themselves are connected. What if the chaotic tumble, the chemical shifts, and the steady radio hum are not separate phenomena, but different symptoms of the same underlying process? Imagine an object engineered not as a simple probe, but as a complex, self-destructing message in a bottle. Its tumbling motion ensures it flashes its light in an irregular pattern. Its shifting chemistry reveals layers of a pre-programmed sequence as different ices are exposed. Its radio hum is a constant carrier wave, a baseline against which the other signals can be measured. This is not a message in a language we can decipher, but a display of intricate, structured complexity meant to capture attention. Scientists remain deeply skeptical of such grand connections, and rightly so. The universe is vast, and patterns can emerge from random chance. Yet the sheer diversity and strangeness of these 25 signals push us to wonder if we are witnessing the first faint threads of a galactic tapestry, one whose full picture remains just beyond our sight. What if we are not just collecting random anomalies, but learning the first few words of a conversation that has been going on between the stars for billions of years? Catching these whispers from the void demands technology that borders on the magical. Our most powerful ears are vast fields of radio dishes like the Allen Telescope Array, where dozens of white antennas scan the sky in unison, listening for the faintest crackle in the cosmic static. These instruments are not looking for a single frequency, but sifting through billions of channels simultaneously, a task so immense it would be impossible without supercomputers. The challenge is not just hearing a signal, but recognizing it as something alien amidst an overwhelming cacophony. Our own planet is a blazing radio lighthouse, screaming with television broadcasts, satellite links, and radar pulses. Even a single cell phone on a quiet mountain can mimic an interstellar whisper. Astronomers must become master detectives, meticulously ruling out every possible terrestrial source, every passing satellite, every glitch in their own hardware before they can even consider a signal as a candidate. The next leap in this quest is the Square Kilometer Array, a project so vast it will spread its listening posts across 2 continents. When complete, it will be so sensitive it could detect an airport radar on a planet orbiting a distant star, giving us an unprecedented chance to hear the faintest of these cosmic travelers. But the hunt is not limited to radio waves. The James Webb Space Telescope peers into the infrared, reading the heat signatures and chemical compositions of these objects with stunning clarity. It can see the specific light absorbed by complex organic molecules or exotic ices, translating a comet's faint glow into a detailed chemical profile millions of miles away. And perhaps most remarkably, this grand search is not just for professionals. Citizen science projects allow anyone with an internet connection to join the hunt, sifting through mountains of telescope data, their human intuition sometimes spotting a subtle pattern a computer algorithm might miss. Every one of these tools is a net cast into a dark and silent ocean, each hoping to catch a single, fleeting glimmer of something from another world. So what are these 25 whispers, and where could they possibly come from? The explanations span a breathtaking spectrum, from the elegantly simple to the wildly speculative. On one end lies the solid ground of natural phenomena. We are still novices in understanding the full repertoire of cosmic chemistry and physics. An exotic mix of hyper-volatile ices, substances that turn to gas at incredibly low temperatures, could explain sudden, violent outgassing events without a visible dust trail. Unknown plasma physics, where a comet's interaction with the solar wind creates complex magnetic bubbles and intense electrical discharges, might account for those coherent radio bursts and strange, repeating pulses. The chaotic tumble and spectral shifts could simply be the death throes of a fragile rubble pile, a world so weakly held together that it is coming apart under the gentle pressure of sunlight. Occam's razor, the principle that the simplest solution is often the correct one, strongly favors these natural explanations. They rely on processes we already know exist, even if we have never seen them play out in such extreme ways. Yet, for a handful of these signals, the simplest explanation may not be enough. The perfectly coherent radio tone, the delayed echo, and the object with no visible outgassing but a strange heat source push against the boundaries of the known. This is where we must carefully and skeptically venture into the realm of the breathtakingly speculative. Could some of these objects be alien artifacts? The idea is not that they are piloted ships, but perhaps derelict technology, ancient probes from a civilization that may have long since vanished. A reconnaissance probe designed for long-term stealth might explain a massive, dark object detected only by its gravitational tug. Its silence would be a feature, not a bug. The concept of a von Neumann probe, a self-replicating machine that uses raw materials from asteroids and comets to build copies of itself, offers a chillingly elegant explanation for a potential family of similar objects arriving from the same region of space. A malfunctioning probe of this type could account for a signal that seems too structured, too clean to be natural, like a stuck record player endlessly broadcasting its diagnostic tone across the galaxy. The evidence for these extraordinary ideas remains precisely zero, but they force a valuable exercise. They make us question our assumptions about what is natural and what is possible. They remind us that the universe is under no obligation to conform to our limited imagination. The true answer likely lies in a mix. Most of these signals will be explained by new, fascinating natural processes we have yet to discover. But perhaps, just perhaps, one or two will remain stubbornly outside every box we try to build, a permanent and beautiful mystery calling us to look deeper. These 25 cosmic whispers form a symphony of the unexplained, a chorus of mysteries carried on the backs of silent travelers from distant suns. We have journeyed from the strange acceleration of Oumuamua to the ghostly gravitational tugs of unseen giants, from the perfect coherent tone that defied nature to the profound silence of a comet that was simply, impossibly normal. Each signal, whether a burst of energy, a flicker of light, or a hidden chemical signature, tells us the same fundamental truth. Interstellar comets are not just simple balls of ice and rock. They are messengers, each one a potential carrier of profound secrets about the formation of other solar systems, the resilience of life's building blocks, and perhaps even the existence of forces and phenomena we have yet to dream of. They have transformed our cosmic neighborhood from a quiet cul-de-sac into a bustling galactic crossroads. So the next time you find yourself under a clear night sky, look up. Let your gaze wander past the familiar constellations and into the deep black between the stars. Remember that at this very moment, silent, enigmatic travelers are speeding through that vast darkness, each one holding a story we have only just begun to learn how to read. Keep asking questions, stay endlessly curious, and let that sense of wonder be your guide. We would love to hear which of these 25 signals captured your imagination the most. Was it the delayed echo from a ghost, the tumbling shard of a shattered world, or the single perfect note that sounded almost like a greeting? Share your thoughts in the comments below, and let's continue this cosmic conversation.